one of those, like $150. Yeah. All right. There are cheaper ones. If you have an Android phone, you can get a emulator for it. See? But only if you have an Android. No, of course not. Because if you have your phone on a test, you'll be photomathing. Because you guys can't be trusted. So, the first one, excuse me, I don't actually have an answer for, so what is it? Well, all right, I guess I'll do this. It is -9 plus or minus the square root of 80. I'll write it out full. 9 squared minus 4 times 4 times -7 over 2 times 4. And you get -9 plus or minus -4 times 7 is 28. Oh, 28 times 4 is 80, and 32 is 112. Brain turned to mush. Yep. Plus or minus root 193 over 8. That's the answer. 2. For number 2, I actually have an answer. It's -2 and 1 1/3. Number 3 is -1 and -1/5. And number 4 is 6 plus or minus 2 root 5 over 2, which of course you would simplify to 3 plus or minus root 5. Do I need to go over any of them? Number 2. So, number 2, we'll change colors, is -2 plus or minus the square root of 2 squared minus 4 times 3 times -8 over 2 times 3, which is -2 plus or minus the square root of 12 times 8 is positive 96. 4 plus 96 is 100 over 6, which is 2 plus or minus 10 over 6, which is 12 over 6. Sorry, -2. Minus 10 is -12 over 6, which is -2. Or -8, or positive 8 over 6, which is 4/3. Anything else? If you can't do these in your head, of course you are doing it with your calculator. 7 and 8 are pretty much exactly the same. What did you have to do? 7 became 2x squared minus 3x minus 1. A great many of you on your cumulative forgot that when you move something over the equal sign, what happens to it? It changes sign. A great many of you forgot that on a great many questions. That's what I was just talking to Riley about. That's something that I shouldn't know, that you bring to the party already, Riley. Right? That's something you should already know. Right? Then, of course, there's your ABC. And the answer is 3 plus or minus root 17 over 4. Number 8, move 2 things, becomes 2x squared minus 9x minus 4. And the answer becomes 9 plus or minus root 113 over 4. Everybody should have been okay with those two. I saw a lot of people with issues here. Right? Remember, if it looks like this, ax squared plus bx plus c equals 0, we can use the quadratic formula, right? As long as it looks like that. That doesn't look like that. What part of that is screwing us up? That. Do you see any fractions here? No. So you've got to get rid of the fraction. Is that something you've been taught in the past? Yes. Are you supposed to bring that with you? Yes. How do you get rid of divided by x? You multiply by x. X cancels there, so now I have 6 minus, what's 2x times x? Minus 2x squared equals, what's 9 times x? 9x. Now make this look like this. Bring that over, bring that over. 2x squared plus 9x minus 6. And now we're easy peasy lemon squeezy because we've got ABC there. All right, now, if you didn't do these questions, now you can. I expect you to do that. Before I stop talking and let you do that question, we're going to fix up number 10. What bothers us about number 10? There are two fractions. When have we ever seen something that looks like this? Sorry. Have you seen that? Many, many times. How would you solve it? You would cross multiply. Does that look like fraction equals fraction? So what would you do? Cross multiply. Have you ever multiplied a binomial by another binomial? Yes, you have. Have you ever multiplied a monomial by a binomial? Yes, you have. Bring the math that you already know. If you were going to somebody's house for a pizza party, would you bring rutabagas? No, of course you wouldn't. Why? Rutabagas don't go on pizza. You know that. What would you bring to a party where you were going to make pizza? You would not bring pineapple. Because pineapple has no place on a pizza either. No. Pineapple can be cooked on pizza and then picked off because, ironically, the taste it leaves on pizza is quite delightful. I know it's weird. Shut up. I just don't like pineapple on pizza, but I like ham and pineapple pizza that's had all the pineapple taken off. Be quiet. Yeah, because you guys don't like weird stuff. Don't give me that. So, this is x plus 3 times x plus 1 equals x times 5x minus 2. Now, everybody that didn't do 9 and 10, do them now. we done? Yeah? There's the answers. Please remember, a bunch of you will have stopped there. Is that okay? It's okay. It's a 3 out of 4. How do you get the 4 out of 4? You simplify, simplify, simplify. Because when do we simplify? Always. When? Always. But surely not every time. Always. Any questions about any of them now? Whoops. Sweet. I'll keep the answers there while we go to the next one. Perimeter of 70. If I have a rectangle, what are the two components of it? Length and width, yes? So what do I know about this triangle? I know length times width equals what? 264. Yeah? And I know length plus width equals what? No. 35. Why is that a problem as it's written right now? Again, you have to bring something from grade 10. Why is that a problem? There's two unknowns. You cannot solve that, can you? Because you don't know what they are. But you do know that L equals 35 minus W, right? And what letter is that? L. What does L equal? 35 minus W. So 35 minus W times W equals 264, right? So 35W minus W squared equals 264, right? So W squared minus 35W plus 264 equals 0, correct? And then once you have that, do you have ABC? And you run it through the quadratic formula and you find that L and W are what? 24 and 11. L equals 24, W equals 11. I don't need to run that through the quadratic formula, do I? Okay. No. Now, when I actually, you know what I kind of do? So let's just do that. 35 plus or minus the root of 35 squared minus 2, 4 times 1, which doesn't count, plus, or times 264 over 2. 35 squared minus 4 times 264 is, of course, is 35 plus or minus the root of 169 over 2, which is 35 plus or minus 13 over 2, which is either 48 over 2 or 22 over 2. So the two possible options are 24 and 11. Then you go back here and that gives it to you. Now, let me ask you this. What if one of those, and this is a what if, it doesn't apply to this question. What if one of those was negative? Is that a number you would even have to consider? No, why not? You can't have a negative distance. Everybody understand? That would be, what do we call those when we get an answer that doesn't work? That's an extraneous root that we learned about at the end of Unit 3, right? Okay, good. And the last one. Number 4, you already know how to do it, but it's a little tricky. So number 4 was rectangle is 23 by 16. If the length is decreased by x, so length equals 23 minus x, and the width is increased by x, 16 plus x, the area of the new triangle is 378. Find the dimensions of the new rectangle. Well, we know that 23 minus x times 16 plus x would have to equal 378, yes? Length times width, 378, right? Right? Then, do we know how to multiply binomial by binomial? Of course we do. 23 times 16, which I can actually do in my head. It's 320 and 48, it's 368, right? 368 plus 23x minus 16x minus x squared equals 378. So 368 plus 7x minus x squared equals 378. X squared minus 7x plus 10 equals 0. And then I can go through it, right? Now, do I even need to use the quadratic formula here? Why not? What does this do? It factors. To what? To what? X minus 5, x minus 2. So what are the values of x? The values of x have to be 5 or 2, correct? So if it's 23 minus 5, what do I get? 18, and 16 plus 5 is 21. What's 23 minus 2? 21. What's 16 plus 2? 18. And I get my answers. Right? Okay. And lastly, what bothers us about 5? Because a lot of people didn't do it. Tell me what bothers you. Why isn't this done? Pardon me? Okay. What else? What else bothers us here? We're no longer dealing with x's and y's, are we? Right? So let me ask you this. How would you solve that problem? You would apply a formula that you brought here from previous knowledge, yes? What is that formula? A squared plus b squared equals c squared, right? Okay. How would you solve that problem? C squared plus 4 squared would equal 5 squared. Why is the second one a problem? Why does it screw up kids who don't really pay attention in math class? Because the C isn't the hypotenuse, right? But did you all know how to do this question? You did, because you're in the 11th grade. So, this question, does this look similar? Do I have some number squared with a coefficient? Yes. Do I have that same variable right there? Does that not look a lot like this? Doesn't it? Which would make this A, B, or C. A. Why is this A even though it's on the right? Because it's with the squared. There's A. What does that make this? B. What does that make this? C. Now all of that, X is my input, isn't it? 28 of you were in my grade 10 class. Is X an input? Yes. And when I input X, what do I get? Once I do all this, what would I get? I would get an output. The output would be the Y value, right? So H is just what? A Y value. T is an X value because T is the independent variable. H is the dependent variable. The longer that ball is in the air, or the less amount of time that ball is in the air, the height will depend upon that time, right? So, even if you didn't see X's and Y's and zeros, you can bring previous knowledge to the party, and then you could do this, right? You would run this through the quadratic formula. But if I run it through the quadratic formula, it gets very ugly, right? So, what is it? What would this be? Because I've written it backwards. What would that be in the quadratic formula? Negative 14 plus or minus the root of 14 squared minus 4 times negative 4.9 times 2 all over 2 times what? Negative 4.9. Barf! Doable? Absolutely, but ugly. Everyone agree? And we've got a real life question here, don't we? This is going to give me an answer that is no good in real life, is it? I want to know how long the ball is in the air. Well, is this going to come out to a perfect number? No, so the ball was in the air for negative 14 plus or minus the square root of blah, and then I had to divide that by negative 9.8. How long was the ball in the air? I just told you. Is that how you would give a time to someone? Of course not. How do you give a time to someone? In minutes and seconds, right? So this question, because it's a physics question, doesn't really lend itself to this type of solution, does it? We want a number. So now, let's learn. We could get the number by doing this all and then punching it all into our calculator, couldn't we? Right? But, like all good teachers, I would like to give you other tools to solve this problem. So here's what you're going to do. Anybody that does not have a graphing calculator that looks like this, if you do not have it, you're going to come up here and take one. You are not just going to take it, though, because they are worth $150 each. You're going to leave me your phone. I used to get kids to leave shoes, but as you know, kids would walk out without their frickin' shoes. As soon as I started taking phones, ain't nobody ever walked out without their phone. Which just goes to show how sick you people really are. But that's okay. If you don't have one of these, you need it. Come and get one. Put a phone in the basket, take out a calculator.
Does it have to be a phone? Can I leave my headphones up here?
Your headphones are worth more than the calculator. I know that. That's what I just said. Now, a great many of you hopefully have a bunch of white space on the page that you're working on right now. Section off part of it. For graphing calculator stuff. Or get your own piece of paper out. I don't really care. Everybody good? All right. See this button right here? Y equals? Everyone see it? It's up in the top left of your calculator that is in front of you. Push that button. You should be looking at a line of y1, y2, y3, y4, and a bunch of blanks. Yes? If you do not see plot 1, plot 2, plot 3 at the top, you must tell me now. Because it means your calculator's in a weird mode and I got to fix it. It doesn't look like this? Oh, that's fine. Just push clear, and that should blank everything out. Bring it here. It's not your fault. It's just one of those things. Drives me up the wall about teaching math. Oh, yeah, don't worry about that. There. Everybody should have a flashing cursor by Y1. Yeah? Okay, now, the next thing you need to see is, see that button right there with X, T, theta, and N? That button right there. So X, T, theta, N. That is your independent variable button. Or, for what we've been doing in class so far, that is the button that will give you your X. Because up till now, we've only been using X and Y, and X is the independent variable. Everybody understand? Everyone's good? Yes. All right. Everything else is normal. Okay? So, let us go back to a question that worked out perfectly. Remember how this one gave us 24 and 11. Everybody remembers that, right? Okay. W squared minus 35W plus 264 equals 0. So, we've got W squared minus 35W plus 264 equals 0. Everybody cool? What there is my independent variable? W. So in my calculator, which only uses X, what would this equation have to look like on the calculator? X squared minus 35X plus 264. That is what it will look like on the calculator, because the calculator has to use X. Now, all of that gave me an output of 0. On my calculator, what's the output? Y. This will equal Y. The Y is already there. Everybody cool? So now, everybody enter this into the first line. So the first thing we have is an X. So what's the first button we need to push? The XT theta N button. And it gives us an X. Everybody see that X? Easy peasy lemon squeezy, right? What's happening to that X in our equation? Being squared. So we're going to push the X squared button, which is halfway down on the left column. Everybody see it? And I'm going to hit that button and, oh look, my X just got squared. Everybody good? Then, minus. Please do not hit the negative button. Hit minus. And now what do I push? 35, and then what? XT theta N. Then what? Plus, then what? 264. Everybody sees this, yes? Now, what we're going to do next is going to be a gigantic problem depending on the way the calculator you have in front of you is set up. Okay? We're going to just do this. We're going to do the next thing and it might not work for everyone. Okay? When you are done, push top right button, graph. Now, everybody is probably looking at a different looking screen than me right now. Right? This is where this gets complicated. Everybody cool? Everybody should be looking at a graph right now. Some of you will only see the two axes. You won't see any line. Does anybody have that situation going right now? Perfect. That's actually a good thing. Right now, the window that your calculator is looking at is wrong for this equation. So we're going to change that. The first thing we're going to do is set up the regular window, what your calculator likes to have. So everybody push zoom. And you will see this mess. Right? Right? Everybody should be seeing this. Push. You can either use the arrow keys to highlight it, or you can push 6. Now, everybody should be looking at this window, and you should see no line at all. Everybody?
No. When I click graph, it did this.
Yes, because you didn't pay attention the first time. It's okay. It's all right. It's okay. So, yes.
When I click graph, it
Because you didn't change your window, like I said. That's because you have stuff on you didn't delete the previous stuff I said. You only were supposed to have that. All right. Is everybody looking at this now?
Snakes on this somehow? Snakes?
All right, is everybody looking at this now? Now, 2 seconds ago, you saw that my calculator had a graphed line on it, yes? But now that I've gone to this, you can see I have no line. Now look carefully. What are the coordinates of that point right there? 0, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it goes up 10, right? So this graph that we have set up, that zoom standard, is a 10 by 10 grid. Now we know that this line will graph, because you saw it. Some of you saw a line, right? So you know it's there somewhere, correct? All right, now, what we're going to do is we're going to manipulate the window to find it. Now, since this was a rectangle question, is it possible to have any x's that are negative? No, of course not. So do we need any of this? No. So watch what we do. Everybody see the button that says window? Hit it. And you can see that my window goes from an x minimum of negative 10. And we knew that. We were down at negative 10. And an x maximum of positive 10. And its scale was 1. Which means every little tick on the calculator is worth how much? 1. So it was negative 10 to positive 10. There were 20 little ticks on the calculator, yes? All right. So we know we don't need the negatives, do we? So let's make our x minimum using our calculator. We're going to make it negative 2 because I want the calculator to slide a little over so we can see the origin. Everybody with me? But we need to go higher than 10, don't we? Because we couldn't even see our line. So it doesn't matter what we make it. Let's make it 50. Now, if I leave this scale as 1, how many little ticks are going to be on the calculator? 50, right? What if I made the scale 2? How many little ticks would be on the calculator? 25. What if I made it 5? There'd be 10. Everybody with me? So let's make it 5. Now, since I am looking for the roots of this equation, where the x's are going to be, do I need very many y's? No, because I only care about where the line hits x, right? So we're not even going to touch the y's, because it's going to have negative 10 to negative 10. It's going to cross the x-axis, yes? Everybody with me? All right, so now hit graph. Everybody cool? Everyone cool? Now, you already know that because of this x squared, this is going to give me one of these, right? What's missing? The bottom of it. If we wanted to see the bottom, what would we have to do? Change the window. Where would I have to make that window changes? On the y, would it be the y minimum or the y maximum? Minimum, because we got to go down lower, yeah? So let's make that minimum. Let's try minus 50. Minus 50. And let's keep the y maximum at 10. And let's change that scale to 5. So now we've got, and then we're going to hit graph. Everybody cool? Everybody cool? Where? Well, did you change your window to match this? Then you just push graph. Okay. Yes. So go back to your window, Jorrit, and make it look like that.
And then I press down, and then it goes in.
Window. Change your window to this. Negative 2. 50. 5.
Establishing it before we go to graph?
Yes. All right. Everybody sees, right? Now, we care about the x values, correct? And you can see that I have two x values, can't you? But you don't know what those values are, do you? So, everybody should be able to graph. Everyone can, yes? So once we've graphed, we may need to adjust our window. But eventually, you will get a graph. Everyone cool? That's where we are right now. What are the values we care about? We care about those values right there, yes? The roots of the equation. Now, our calculator can tell us that. Look at the buttons you see there. Look at the second functions. What button do you think we would want to push, don't push anything, to find those two values? Don't push anything. Just look at the buttons and the second functions. Calc. Calculate. We want to calculate. How do we get those second functions? We push second calc. So to find these, we are going to push second calc. And now look at what I have. I can find all kinds of stuff, can't I?
Yes.
Which one of those do you think I am seeking right now? Don't push anything. Talk to your neighbor. Look at those 7 choices. What one do you think we are seeking? Noah, what do you think? We are seeking a value, possibly. What else? We are seeking an intersect because we want to see where the line intersects the x-axis. Nope. Nope. We're not seeking a minimum because this would be the minimum, right? The lowest value. Maximum will be the highest value. How high is this parabola going to go? Infinite. So we can't be seeking a maximum. Okay. What we are looking for here, second calc allows us to find all kinds of stuff. But right now, we are looking for the point where y equals 0. Because those are the roots. Because those are the x values. So here we want choice 2, which is 0. So everybody either highlight 2 or push 2. And now we get to weirdness. Everybody good? Now, you can see that I have a 0 here and a 0 here, correct? And the calculator is asking me for the left boundary. Which direction is left? That way, right? So I'm going to take see my flashing little cursor there? Using the arrow keys, is my flashing little cursor right now left of the 0 that I care about? It's flashing right there. There's the 0. Am I to the left of it? Yes. Got your N yet? Good. Everybody understands what I mean by left, right? See what I did there? Left, right? Okay. Now, have we all pushed our button so our cursor is left of our 0? Okay, so now we're going to push enter. Now what is the calculator asking me for? The right boundary. So what do you think I have to do with that flashing cursor? Move it to the right of the 0. So I'm going to hit right. Now, am I to the right of my 0? So I'm going to push enter. And then it's asking us, do you want me to guess at this? Yeah, we do. This is what we're asking you to do, right, calculator? So we push enter. X equals 24. Everybody see? And we knew X was going to be 24 because we did this the long way, right? Now, all of you already know that the other value is 11, right? Find it. So, on your own, second calc 0, and try to figure that one out. Go. And this is all recording, by the way. So I'm just going to write out what we did. And we all knew it was going to be 11. Was everybody able to make their calculator show them 11? Everybody was? Yeah, yeah? Yeah, yeah, yeah? If you're a little confuzzled, watch right now. Second calc. What do I want? 0. And I already know this one's 24, so I've got to move my cursor now till I am left of the other one. Now, sometimes it's really finicky. So please look at what's happening with my numbers here. See how my y is still negative? Everyone see that? Once that y becomes positive, am I going to be on the other side of the 0? So now it's positive. Is my left boundary on the left of my 0? Enter. And now as soon as that y is negative, is it going to be on the right? It's negative. So now I'm good, yes? Enter. Yes? Well, yes. 11. Everybody cool? All right. Now, your calculator window is all messed up now, isn't it? Because we set it at -2 to 50 and 10 to -50, right? So now all of you hit the Y button, clear that equation, and give me the real life answer to this. Try to punch that into your calculator and give me the real life answer. See if you can figure it out. It's no problem if you can't. This is your first attempt. So get to the y equation and try to enter that. And then graph it and then tell me the answer. Why does that say x when I have a t? Does it matter? No, because I know that's my independent variable. Minus t squared. Has everybody gotten to there? At least. Yes? Now, when I graph it, I have not told my calculator to change its window, so it's going to use its last window, yes? It's kind of visible, isn't it? Right? But is it very good? It's not very good. So I'm going to change my window. Everybody try. Now I can see that there's a lot of business around the origin here, isn't there? Right? So I should get that origin back in. Well, the easiest way to do that, again, is zoom 6 standard. And that takes me back to this 10 by 10. That's not bad, right? But I can see that it's really hard to make out this 0, isn't it? Right? So I want a better view of these. Right? And I have a couple of options. One, I could change the window down to like -2 to positive 1, 2, 3, 4, and change the y values. That's one thing I could do. I could also do this. Zoom. See number 1 there? Zoom box. And I can draw a box with my arrow keys. My arrow keys do not work very well on this thing. But you can see my flashing little cursor there? Everybody see it? Right there? So I'm going to get it to where I want it. I'm going to push enter. And then look, I can draw a box around what I want. Because I only care about those zeros, yes? So when I stretch this box out, once I'm past that 0, enter. There it is. Only what I care about. Agreed? Everybody cool? Now, what am I trying to calculate? The x values, yes? Now, let's look at this carefully. The x value is the time, isn't it? Can time ever be negative? So do I even care about that 0? No. So could I have changed my window to have no negative x values? Because I don't need them. There's no such thing as negative time. So I could have gone to window x minimum 0. Everybody understand what I'm saying? Now, I want to get to here. So I got a calculator, right? Second, calc. What do I want? 0. Now I need the left boundary of this 0. So I got to move my cursor till it's on the left of that. So I'm going to move my cursor along. And you can see my y values are getting smaller, right? Which means the cursor is coming down the line. Oh, there it is. Is it on the left? So what can I do now? Enter. Right boundary? Well, sure, calculator. Am I on the right of it now? Enter. Yes. Well, I would think so. I just took a long time to enter it all in. How long was the ball in the air? 2.99 seconds. Everybody understand? Is everybody cool? Everyone's cool? Okay, now let's stop for a minute. Let's go back to a previous question that gave us a weird answer. For example, let's look at number 4 right here. Everybody cool? Now, using your regular calculator, which you don't need to actually do, I'm just going to show you. The roots here are 3 plus or minus root 5. Agreed? Everyone agree? Okay. So 3 plus root 5 is 5.236. Everyone agree? And the other one would be 3 minus root 5. Everyone agree? 0.764. We're going to round that off. Is everybody cool? All right. Now, go into your y. Try to figure out how to enter that, because it's not what you see. Enter it and graph it. Do not yet find the zeros. First thing you got to do is figure out how to put that into your graphing calculator, your GDC. Graphic Display Calculator. So what do I got to do with this before I can put it in here? You got to move the 4. That's it. So to put this into my calculator, it's going to be what? X squared minus 6x plus 4. So let's do that. X squared minus 6x plus 4. Everyone agree? Now, I'm going to hit the button, graph. Think about what my window's set at. Remember I set that zoom? Do you think I'm going to see anything? Let's see. I saw a little bit of it. So my first step is always go back to my standard zoom. Zoom 6. Does that show me enough to work with? Okay, I want my zeros. Second, calc. 0. Am I to the left of that one right now? There's my flashing cursor. Am I left of it? Enter. Now I need to get to the right of it. How will I know when I'm to the right of it? What will happen to the y values? No, they're already positive. They will go negative because I've passed the x-axis. Are they negative now? So am I okay? So can I hit enter? Do I want it to guess? And if I have done this all right, what should show up? 0.764, correct? 0.764. Everybody cool? And if I've done it right, the other zero should be 5.236, right? Second, calc, 0, left boundary. So this time, am I to the left of this 0 already? Am I? So could I hit enter right now if I wanted to? I could. I'm going to bring it around. How will I know I've started going back up? What will happen to the y values? They'll start getting bigger. Oh, now they're starting to get bigger. So there's my left boundary. How will I know when I'm to the right? The y values will be positive. Can I hit the button now? Enter. Yes? Please do. Hey, 5.236. Do you need the graphing calculator? No. Can you do pre-calc 11 with this? Yes. A great many of you people, and this I've taught this course many, many times, as soon as I get out this calculator, you have trouble using it, you all of a sudden think you can't do math. Is that true? No, that's why I didn't let you touch this until we had done a ton of them with our regular old piece of garbage calculators. Everybody with me? If you are having trouble using this thing, is that anything to be discouraged about? No, because you can do the actual math. When? Every time. Everybody good? I have said this before and I have said this again 1,000 times to the kids that have been in my class before. There is calculator skills and there are math skills, and they are separate things. Bad on your calculator does not mean bad at math. Everybody good? Yeah? Okay, now, listen to me, please. I want you now to take some time, maybe, well, class is only 13 more minutes. We've got a bunch of roots, yes? Practice graphing. Okay? You know what the zeros are going to be because we've done the real work for it, right? Practice graphing so you can move the window around and find the zeros on the graphing calculator. Everybody good? You choose. It doesn't matter. We've got a lot of them. Right? Like here's one right here. I know it's -2 plus or minus root 10. Do that with your calculator, which we knew it was going to be about 1.1 and about -5.1, right? Try that. Enter that. Graph it. Find the zeros. Everybody cool? Try a few, especially if they look like these, where they're not normal. Okay? Try some. No stress. Nothing to worry about. We're just practicing. This is another good one to check, because this one's going to be about 2.75 and about negative 1.25. Yeah. Hey. You know, right?
Yeah.
Okay, just making sure. And the last thing I want to remind you of is this. You don't need to write this down if you don't want to. Solving quadratics. 1. Factor whenever you can. That might be enough. For example, two, you can complete the square. When you complete the square, B is even and A equals 1. That's the best time to do it. Or number 3, you can use the quadratic equation. Negative b plus or minus the root of b squared minus 4ac over 2a. And that always works. And I've given you a fourth one now, the graphing calculator. If you didn't write that down, I did record it, and it's all there for you. Yeah. Ladies and gentlemen, listen please, one last thing and then I will shut up. Tomorrow, I'm not going to be here for the whole block. There's a rugby team coming from Kelowna to play a game against Bateman. They need a referee. So I'm going to be here at the beginning of the block. I'll give you your quiz. Then I'll be leaving and Miss Purvis will be in here. She will be presiding over you doing page 84 to 87. That is your work for spring break. Up to page 87. But I'm giving you a whole period tomorrow to do it. So you'll probably go home with no homework. Go.
And can I do my lunch, or can I do my test at lunch?
Sure. Okay? And I'll remind you of this tomorrow. In case I forget to do this tomorrow, you're going to solve all these by the best method, your choice, right? But I want you to make sure you do complete the square at least 5 times. Okay? You have 4 methods to choose from. 1, factor. 2, complete the square. 3, quad formula. 4, GDC. I only want you to try a maximum of 5 5 max with the GDC tomorrow. Okay? So you got to do at least 5 complete the squares, maximum of 5 with the GDC. All the rest of them, you're either using factoring or the quadratic formula. Or you can do complete the square more than 5 times if you're comfortable with it. Okay? But I don't want you using the graphing calculator for more than 5 of them. Everything else you at your discretion. Once you've hit 5 for complete the square. And on this page right here, I've told you the good times to use complete the square. When b is even and a equals 1. And any way you can get a to equal 1, even if you factor. Cool? All right. Class is over in 5 minutes. If you're done messing around with the calculators, come up, get your phone, hand them back. If you're not, keep messing around for 5 minutes. Emma, when are you going to write your tests? You owe me tons.
Could I do the cumulative?
You want to do the cumulative instead of the other 2? Then it's your only chance at it.
Yeah.
Fine with me. When do you want to do it? Has to be before spring break.
I was going to say tomorrow.
In class? Instead of doing this practice, we just do this practice at home over spring break? No problem at all. Deal.
Would I be able to write it in?
Of course, because I'm going to be doing a quiz and talking up here. That's no fair to you. Okay. And amazingly, ain't nobody leaving without a phone. I used to laugh when kids would walk out without their shoes. And then it happened over and over and over. And then instead of laughing, I had to start to cry.
They did it on purpose, right?
They would like to say they did it on purpose. But they didn't.
That's not one of the things you just forget. Like, you're going to be off balance. And you're
I know that, Jack.
I know. I'm just wondering.
I know how much it bothers. No, it's proof of what you people actually think is important. And you have the audacity to say to me that you are not addicted to your cell phones.
See, I'm just worried that my dad would like kill me. That's what I'm more worried about.
Do you watch